Welcome to another episode of our video tutorial. Today we'll be looking at the power source dependent smart socket, a device designed to control your load based on the active and selected power source. And the reason is because of the part of the world I'm from, Nigeria. Here most times we are often subjected to total blackout or partial blackout, which also result to people falling back to the use of gasoline and diesel generators as their backup power supply. And often and most times we find ourselves turning on different appliances and turning them on depending on the current power source. And so the invention of this device, the power source dependent smart socket. The device is designed to control your load depending on the available power source and the preset power source. So here on the screen we have our mode, which is auto, which means the device is currently operating automatically. And then we have the power source, and that's the desired power source which the device is supposed to turn on the connected load. And then down we have the power source, which is current active power source. And like I said, I am currently using my backup generator for power at the moment, as power from the grid is not available. Down on the status you see off, and that's because the load is currently off. And then there's a countdown there, which is a 2 minutes countdown, designed actually especially for my refrigerator, as this appliance is used to power my refrigerator. At the end of the countdown, it will either turn on or remain off depending on the current source, and in this case it will remain off because the source is from the generator. So you see the countdown is complete and the device is still off. So what are we waiting for? Let's build our own and let's get started. For this build, you will need these components: 5mm LED, 5V 10 amps relay, terminal blocks for connection, 3 1K resistors, 2.2K resistors, 1 10K resistor, 1 N4007 diode, a buzzer, female pin headers for the microcontroller, ESP8266 microcontroller, and then a couple of male pin headers for the push button and the LCD. And then of course you'll need a push button, 2 NPN transistor. You can use BC547 or 2N222. I am using the 2N222 transistors. And then we need a capacitor. For the circuit, I have decided to use my own custom-made PCB board, as for me it's more convenient to use a PCB board. And for the design, I've used PCB Wizard. It's a very old software, I know. I find it very easy to use, and I also find it very easy to make my own custom components there. So I have used it for the PCB designs. And then for the hose, for the little components, I've used 0.8mm drill bits. For the medium size through components and devices, like the relay and the terminal blocks, I have used 1mm drill bits. For the mounting hose, I use 3mm drill bits. And once you've gotten all the components you need, the next step is to go ahead and solder everything together using the circuit diagram. When soldering, first thing you do, for me personally, I like to solder the small components first. After that is to connect the LCD to the device, and then we run our test program. So here we have our LCD, positive pin here, one, connected. So for the device, the housing of the device, I am using this 6 inches by 3 inches patchwork box, originally designed for the double 13 amp socket. And then to mount it on the wall, I've also attached this 3mm acrylic sheet. I have also opened the 5mm hole here so I can actually screw it to the wall. And then for the face, that's the cover. I have also used the same cover designed for the double 13 amps socket. And then on the cover you can see markings. I have made markings for the two LEDs, marking for the display, and then here at the bottom I have made markings for the push button. At the bottom also I've made 2 markings for the wires, so 2 wires will be going inside there. And then to open these holes, I'll be using my Dremel tools. It's been serving me for the past 5 years faithfully. So let's get started. Have our device installed, front panel, back panel, inside the control unit, and then to display. Okay, so you see the mode. The mode is the operating mode of the device. Currently is operating in auto mode, and then you have the power, and that's the power source the device, which is the fridge, the power source it's supposed to work with. And then you have the source, that's the current active source. And then down there you have the status, currently it's on. And yeah, you see NEPA there in this part of the world, Nigeria precisely. NEPA is also another name for grid. So I'll go ahead and switch it to gen. Now it's in manual mode, switching to gen. As gen mode, you can see the status is off because the current power supply is from the grid, that's NEPA, and the power source the fridge is supposed to work with is generator, and the load is off. If I switch it back to the grid supply, it comes up automatically. And then the power information is sent to this device using the ESP-NOW protocol. Here I have my automatic power transfer switch. That's the automatic changeover switch. It is powered by the ESP8266 as well. So I took advantage of that to wirelessly communicate with both devices using the ESP Now protocol. Going back, of course, everything is working.